let's see a sample reaction of the E2. And let's take this molecule, so this is chlorocyclohexane, and we will react it with our base. And I won't typically use hydroxide. I'll typically use an alkoxide. In this case, this happens to be methoxide. That's the specific type of alkoxide. Anytime you use hydroxide, typically you have water as a solvent. Now we're not using hydroxide, we're using methoxide. Typically for methoxide, we'll use methanol as a solvent, which normally I wouldn't write it. I'm writing it this way to highlight the fact that it's protonated methoxide. Normally when I write methanol, I write the CH3 first. Doesn't matter. So that's our solvent. What's going to happen in this reaction? What's going to happen in this reaction is the methoxide is going to act as a base. In the E2, we need a strong base, and we have one with methoxide. And the methoxide attacks that hydrogen. Now, there are a lot of hydrogens in this molecule. Which hydrogen gets removed? It's the one that's next to the chlorine, and there's a way to refer to this hydrogen. So the chlorine is said to be attached to the alpha carbon. Next door to the alpha carbon is what we call the beta carbon. Not very fancy. So next to alpha is beta. We are going to remove specifically hydrogens on the beta carbon. So we're going to remove, people just refer to these as beta hydrogens. So here's our beta hydrogen. We're going to make a new bond to this beta hydrogen. Hydrogen only makes one bond. So as soon as we make a new bond to that hydrogen, we're going to have to break the CH bond. To break that bond, we start the arrow in the middle of the bond. And we're going to move those electrons to where they're going to go. And we're going to form a double bond. We're going to make alkenes in these eliminations. Remember, eliminations make alkenes. So here's our alkene forming by adding a new pair of bonding electrons between the alpha and beta carbon. Now, this alpha carbon, we haven't shown it, but there's also a hydrogen on there. It has a full octet. We can't make a new bond to that carbon without breaking an old one. And what happens is the bond that we break is that carbon-chlorine bond. Those electrons get dumped on the chlorine, and in one quick step, we form a new alkene between the alpha and beta carbons. We're going to lose chloride, and that chloride will go with whatever the counterion is to our base. So we had sodium positive. We'll have sodium positive with our chloride leaving group, and our protonated base. And our protonated base will simply be methanol. We won't normally keep track of all these side products. The star of our show in an E2 is making the alkene. So this is our true product, but other things are formed in the reaction. If we look at this energetically, and here's our reaction coordinate, this looks something like this, the energy diagram. So we have a starting material, we have a product. It's a one-step process. So since it's one step, there are no intermediates, no carbanions or carbocations or radicals formed. And this reaction is downhill because we neutralize our base. We started with a highly reactive base, and that reactivity is now gone. The anion was replaced by a nice stable chloride, so it is a downhill process. So those are some of the basics about the E2. Now we'll talk, in later videos, we'll talk about specific features that are important to determining whether the E2 occurs.